Let's spend at least a little time talking about the scientific work that you did in the later years of your career on quasars, X-ray sources, gamma ray bursts. You worked on those too. Would you like to tell us a few words about that?
Yes. X-ray observations were very interesting because the phenomena that we have discussed, especially quasars, black holes, they stand out in the X-ray sky much better than in the optical sky. If you were to count where 3C273 ranks in the optical sky, I've never done it, but you start with Sirius and then you go down. My estimate is that it is of the order of 1 million or so.
About that, yes, I think that's right. 1 in a million.
Yeah, 1 in a million. You encountered the first quasar in the X-ray in the X-ray collections everywhere. Radio galaxies, I think quasars in fact dominate even over radio galaxies in X-ray surveys. So you get an enormously rich sample if you do the work.
Yeah.
That was so attractive that I, in the 80s, at the suggestion of, I think, Riccardo Giacconi, went to Germany a number of times to assist them in preparing a satellite called Rosette, which in fact worked and which has done beautiful work on making a survey of almost the entire sky. There's somewhere 1 or 2 thin strips that are missing, but it is great work. And as I say, that has been, and in the meantime we did work at Palomar on positions confirming that these X-ray sources were actually quasars, etc., or what they were, and got a very rich beginning of a sample. Jim Gunn was also involved in that, and Don Snyder. And Jim Gunn, by all this work, was moved to start his Sloan survey, which just covers the whole, covers enormous areas to enormous depth in a way that is just awesome.
Awesome, totally
I
awesome.
would say.
Yeah.
And, but the move to X-rays was essential to make it efficient. So difficult to find quasars in the optical sky.
Why did you get drawn to gamma ray bursts?
Oh, just because they are there. They were discovered actually in, I think, perhaps 1966, but kept secret because these are observed by satellites to check on whether the Soviets kept to the ban.
Yes.
Yeah. And the amazing thing was that as soon as they started the system, the first alarm went off. Thank God they did react and did not send anybody to Moscow to let them know. And that's because typically at the sensitivities that we talk about, there is 1 or 2 gamma ray bursts in the sky per day, sometimes 3. And I was intrigued by that. Very difficult, because their durations go from 20 milliseconds to an hour.
An hour or so, yeah.
Something like that.
Yep. Mm-hmm.
The astounding thing is that I don't understand at all is that if you go to much higher energies yet than can be done from those satellites, that they last much longer. I don't understand that.
Is that right? I didn't know that.
Ontzettend long. But the count is slow because once in a while you get a photon at these very high energies. I don't understand it. But anyhow, I thought I would use the methods with V over VM, etc. But with gamma ray burst, that I think they won.
Okay.
Yeah.
Let's switch our attention to administration. You've done a lot of different administrative jobs, ranging from executive officer, which is like department chair for Caltech Astronomy. Then you headed the division of physics, math, and astronomy.
Yeah.
You were director of the Hale Observatories. We probably should explain what that is.
That's right.
Right. So let's review those years, and I'll lead into it by reminding everybody that an upshot of something that happened while you were holding those jobs was the dissolution of the Hale Observatories and the separation of Carnegie from Caltech. So why don't you tell us about that and the events that led up to that?
That's right. Yes. Yeah, it had to do with appointments to the staff. The Hale Observatories was essentially Palomar plus the 6-meter telescope, also on Palomar. It was used by the staff, by staff members. Staff members were chosen from the Caltech faculty in astronomy and from the Carnegie astronomers. And there was an observatory committee, and the observatory committee took care of all the business. It would appoint further staff members if they were qualified from either one or the other institution. It would several times per year invite all the so-called staff members to submit proposals for use of the telescopes. It would look at the proposals and vote to assign time, as it were, and then that was the main role. But one had to be a staff member.
To use the Palomar 200-inch, you had to be called a staff member in Hale Observatories.
Yes.
Okay.
Right.
So just because you were a Caltech faculty member did not necessarily mean that you could observe with the Palomar 200-inch.
Correct.
And same for Carnegie.
Well, Carnegie only, I said yes to the Caltech thing because you need to be an astronomer.
Yeah.
But all astronomers at Caltech were staff members, and observing astronomers, of course.
Yes.
And the Carnegie people, obviously, there was practically no theory at Carnegie.
I think that's true.
Is that right?
Yeah.
So that situation existed. There was a proposal. Curiously, it came from Caltech, my own institution, to appoint somebody who became controversial because he was not somebody that one considered, I think in both institutions as at least by most staff members, as somebody who was not of the caliber. And so it was during that episode that there was considerable unhappiness about what was going on. And I cannot remember who made a proposal that that person should be appointed. Mm-hmm. It might have been somebody from Carnegie, actually. Mm. So, but anyhow, what happened was that I looked at things and realized that that the situation was not very agreeable in terms of the staff membership. There was also the question of difficulties not at the top, but at the administrative level between Jesse Greenstein and the people at Carnegie. So
disagreements over all kinds of things?
Yeah,
I see. Mm-hmm.
Yeah. And so anyhow, I decided somewhat abruptly to, on the 22nd of November, I think, 1979, I wrote a letter to the two presidents indicating that I was proposing that we separate. I wrote that I felt that the combination of the two parts was not more valuable than each part separately, and that I therefore proposed that the two separate, and that I would resign on the 1st of whatever it was, 1980, as director, and would not take part in the discussions about my proposal, so that two administrations and the astronomers could decide really what they wanted. Well, needless to say, they adopted my proposal.
Why do you say needless to say?
Because you know that is you know what is the current situation. No, that should be said here. Yes. So the upshot was, in any case, that the separation took place, and I am almost certain that if we had been together still, that Caltech would not have two Keck telescopes, that Carnegie would not have the Magellan telescope, that we would not be pursuing together, of course. Sorry, Caltech has, that's the wrong thing to say, but I mean, we got into funding, etc., and so on, cooperative. We know, we work with UC, ma'am, and of course Carnegie worked with many other institutions.
Maybe what you're trying to say there is that it was a little too comfortable, that relationship, and when it was dissolved, each side had to work harder in order to stay at the forefront on its own.
And it led to a fantastic
flowering.
I think it led to a reinvigoration of both places. Mm-hmm. I think it was also true that in terms of both institutions felt that the cooperation was something that was going on, and if an initiative was to be taken, perhaps the other one would do it. I was dumbfounded. To be sent a proposal for my judgment by the National Science Foundation of a proposal written by Babcock to start an observatory in the Southern Hemisphere.
What year was that, roughly?
Well, I was still director.
I see.
So.
Oh, that's very interesting.
It was amazing.
Uh-huh.
I sent it back to Jim, whoever our man was in the National Science Foundation, and I said, as you can imagine, I'm not. There is some prejudice on my, so I will not judge it. But
So you're telling us this as a barometer of the close degree of coordination and collaboration that was.
Yeah, you're right. Yes.
Well, I think you're right that both of these organizations have gone on to do great things since
Yeah.
then. Yeah. If you don't mind, let's just sort of look to the future a little bit.
Mm-hmm.
I have a reflective question here. There are some major trends in optical infrared astronomy going on right now. One trend is the trend towards huge telescopes, which are going to be very powerful, but there are going to be fewer of them than there have been in the past. Specifically, there are 3 big telescope proposals that are building now, and the number of astronomers per telescope to use them will be bigger than we've had to deal with in the past. That's trend number 1. Trend number 2 is the use of adaptive optics on ground-based telescopes to capture at least some of the super resolution that's been possible with Hubble, and in some cases even exceed that. And the last trend for me is the enlargement of the focal planes and the total number of pixels that we can bring to bear on the sky, and consequently the huge avalanche of data that come from one of these telescopes every night. So those are 3 trends I can think of. I invite you to look at those trends, extrapolate going forward, and tell us, with your crystal ball, what's going to happen in astronomy. Is Maarten Schmidt of the future going to go to the world's largest telescope and have 6 nights all to himself to study quasars or whatever?
No.
No. So what do you think we'll be doing?
You'll get very few nights. I think the total.
Do you think there'll be huge collaborations and cooperation?
How has the astronomer population of the United States developed, by the way?
I looked at that myself maybe 15 years ago, and there was an enormous increase from 1960 through 1995, like factor of 5.
Yeah.
Since then, probably less of an increase, but probably still continuing to expand.
Yeah.
Definitely more astronomers with time.
Yeah.
More astronomy departments and more students.
Yeah. Point number 2 was?
Adaptive optics.
Fantastic. Beautiful. And
some people don't believe in adaptive optics. They don't really think it can do the job or ever really work.
Oh, I'm sure it can. Why not? The question is, how do you gauge the atmosphere? How do you do and isn't it true that at Tololo they have all the time a artificial star?
Well, laser stars on telescopes make artificial stars.
Sorry?
The laser guide star pretty much solves that problem.
Yeah.
Yeah.
No, I think it's fantastic, and I don't see why it couldn't work. I thought it has already in some cases done fantastic work.
Mm.
And
my favorite figure is that the 30-meter telescope relative to Hubble, 12 times bigger in diameter, sees 100 times fainter.
Yeah.
With adaptive optics.
Yeah, yeah.
Provided it's working.
Yeah. Yeah, but that's immensely important because we need that, and we cannot always rely on space.
No, I think
Space is a very expensive way to go.
it's expensive and it depends on the political will.
That too, yeah, yeah. And then point number 3 was?
Point number 3 was the enormous increase in the amount of data. What's that going to do for us?
No, I think it's very good. The thing I would worry about, potentially, without being critical of a new generation, because that's unfair, about whether the ideas about what you're trying to achieve are of the quality that such data streams warrant.
So let's go back to the 50s and early 60s at the beginning of your career. This was maybe 10 years before my own. I think we would share the view that that was an enormously exciting time because so little was known.
Yeah.
And because we could see better detectors coming along.
Yeah.
And the end of the photographic plate,
Yeah.
something better than that, right? So there just seemed to be an endless array of interesting questions. My question to you going forward, on the other hand, we've learned a lot in the meantime. My question to you going forward, do you feel that the array of opportunities is as rich as it is in astronomy going forward from now as it was when you were a youthful astronomer?
I'll answer that in just a moment, but first I have to take back my mark about space science. The way I understand it, Gaia will be able to essentially get parallaxes for every star in the galaxy, except for absorption. That is incredible. I mean...
Good point.
So, I think let everybody have at it, and I don't even know exactly how it is done, but it is done by techniques in the focal plane that are incredibly clever, and that it can be extended to such accuracy is just, to me, I find it incredible.
Okay, here's my last question. If you were starting your career today, where do you think you would be focusing? What do you think for you would be the most interesting and fruitful areas?
That's very difficult to answer because there's an if in there, and so I think I cannot answer about myself, but I think I'll come back almost to my answer to the previous question. It is the young people who enter the field and see things for the first few years with fresh eyes, not influenced by I don't know what, that really may be the next step forward.
I like your answer. Instead of trying to preview what the future's going to hold, just have faith that the next generation of astronomers are going to uncover questions that are just as exciting as... Thank you, Maarten. I think this has been a wonderful time spent with you, and I really appreciate all of the great anecdotes that you've told us that give such a vivid sense to this historical epoch that you pioneered. Thank you.
Thank you, Sandy.
Thank you.